Hello, guys. This is just a nice little summary video to look at Pythagoras, and what's the point of Pythagoras? Now, I don't even bother writing it anymore because what we see Pythagoras' formula to be, or what we know it to be, is a squared plus b squared equals c squared. In other words, if we know the short side length and square them, add them together, a squared plus b squared, that equals the square of the long side. But really, when it's all said and done, what problems are we going to have to find if we're doing any Pythagoras questions? And that is, we're either finding the long side, or as we call it, the hypotenuse, or we're finding the short side. In other words, these sides here connected to the right angle. So we're either finding the long side, which is opposite the right angle, or we're finding one of the short sides. And what are the formulas we need to know? Well, if we're finding the long side, we use a squared plus b squared equals c squared, or, let's do a little bit of a neater one, the square root of a squared plus b squared equals c. Now, those of you who are looking at this and going, what? Either we do the square root at the end for this one, or we include it into the formula, which is what we're doing here. Alternatively, if we're finding the short side, it's c squared minus a squared equals b squared, or b equals the square root of c squared minus a squared. Long side minus the short side. Now, some of you guys probably spaced out while I was actually saying that, so let's do a couple of examples. The first thing we need to say, or look at with these, is what side are we looking for? The short or the long side? We're looking at here, they're next to the right angle, so we've got that one and that one, so we've got both the short sides. That means we're looking for the long side. So that means we can use our formula, c equals the square root of a squared plus b squared. Now, in this case, there's no c. So what do I actually mean by c? Well, in this case, c, or the long side, is actually, we've labelled it x. So x equals, and let's substitute the values we know into the equation, 3 squared plus 4 squared. Now we put our equal sign underneath, and we evaluate that, or in other words, find out what that actually equals. So that's the square root of 3 squared, which is 9, plus 4 squared, which is 16. Let's keep on going. Equal sign straight underneath. The square root of 9 plus 16, which is 25, which equals, if we punch that into your calculator if you don't already know it, equals 5. So in other words, x, this, equals 5. Now I didn't put units, but let's say 5 centimeters. Now let's have a look at a different example. Which side are we looking for? Well, we've got one short side, and in this case we've got the long side, so we're actually looking for the short side. So the short side, we use the minus formula. B equals the square root of c squared minus a squared, which in this case, b, or the short side we're looking for, now it doesn't matter which one's a or b, but this one, n equals the square root of the long side, 10 squared, minus 5 squared. Let's simplify that. 10 squared is 100, and 5 squared is 25. And so 100 minus 25 is 75. Now, if you type that into your calculator, you're going to get 8 point something, 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 And we don't really like that. What's the point? What's the point of us actually turning that into a decimal and then rounding it off? It's much easier to just leave it as an exact value. In other words, a surd. So in this case, your answer is b equals 75. Or in this case, up here, should I say square root 75? That is a number. If we type it into our calculator, it will continue to be a number, and we'll know exactly what it is as a decimal. But for the moment, we can leave it as an exact value as the square root of 75. Amen.